Hello, everybody. This is Shankar from Global Intelligence Network. India achieved a defining milestone on April 6, 2026, at the Kalpakkam Nuclear Complex, where something truly historic unfolded. The indigenous 500 megawatt prototype fast breeder reactor attained first criticality, marking the moment a sustained nuclear chain reaction became self sustaining on Indian soil. Built by BHAVINI, this is not just another reactor. This is a system that produces more fuel than it consumes. Yes, more fuel than it consumes. It operates on uranium plutonium fuel and unlocks the second stage of India's long envisioned three-stage nuclear program, a strategy originally designed by Homi Jehangir Bhabha. A vision seeded in 1954 has now entered execution. 72 years of intent, 22 years of construction. This is not delay, this is disciplined persistence. Now let's get to the numbers that define the scale of this achievement. 72 years since conception, 22 years to build, approximately 7,700 crore rupees in cost, 500 megawatt generation capacity. India is now the second nation in the world after Russia to operate a reactor of this class. And here is the deeper story. India holds nearly 25% of the world's thorium reserves, enough to power the nation for 3 to 4 centuries. This is not just energy security, this is civilizational leverage. So what exactly is criticality? It is the precise moment when a nuclear reaction sustains itself without external input, like a fire that no longer needs ignition. It is delicate, it is complex, and it is the most decisive phase in a reactor's life cycle. And India has achieved it. Now understand the technological leap. Conventional reactors consume fuel. Fast breeder reactors generate fuel. They convert uranium-238 into more fissile material, while simultaneously enabling thorium to transform into uranium-233, which becomes the foundation of India's long-term energy independence. Now consider the engineering challenge. This reactor is cooled using liquid sodium, a metal that burns on contact with air and reacts violently with water. Yet India has successfully built a 500 megawatt reactor around this system, equipped with passive safety mechanisms that ensure automatic shutdown even in the absence of human intervention. This is precision engineering at the highest level. Globally, multiple advanced economies attempted this technology and stepped back. The United States, Germany, and the United Kingdom did not operationalize it. Today, only Russia and India stand in this space. That is the strategic reality. There is another dimension that demands attention. Fast breeder reactors also produce plutonium in significant quantities, which expands future energy pathways and strengthens long-term strategic flexibility. Now look ahead. India's nuclear capacity stands at approximately 8.78 gigawatts today. The target is 22 gigawatts by 2032 and 100 gigawatts by 2047, a 12-fold expansion within 2 decades, from aspiration to inevitability. But this story is not just about technology. This reactor was built by more than 200 Indian companies, from high-precision manufacturing units to heavy engineering firms, representing a full spectrum national industrial effort. This is what self-reliance looks like in practice. Now a reality check. Criticality does not mean immediate power supply. What follows is a phased process of testing, calibration, regulatory validation, and gradual power escalation. Full-scale commercial generation is expected later in 2026. The engine has started. The journey has just begun. And finally, a moment of reflection. In 1966, Homi Jehangir Bhabha passed away, but his vision did not. Decades later, that vision stands operational. India has not just activated a reactor, India has activated a long-awaited future. This is Shankar from Global Intelligence Network. Stay informed, because the world is not slowing down. It is accelerating and reshaping itself in real time. Stay aware, stay balanced,